For decades, tobacco companies used one simple phrase to delay life-saving regulations. Correlation doesn't equal causation. They weren't wrong, but they were lying. I'm from Stats Explained, and today we're exposing how the most basic statistical principle has become a weapon against scientific progress. If you've wondered why studies seem contradictory or companies dodge responsibility, this will change everything. Hit subscribe for more statistical deep dives. This innocent principle has been weaponized. When applied to tobacco and lung cancer, asbestos and disease, or climate data, it becomes a tool for denying evidence and avoiding accountability. We all know the ice cream drowning example. But what happens when this same logic dismisses real health threats? The tobacco industry delayed regulation for decades using exactly this argument. That delay cost millions of lives. This misuse creates four critical problems. First, we dismiss legitimate correlations instead of investigating them. Second, we treat all correlations equally when some deserve serious attention. Third, we ignore that scientists use sophisticated methods like Bradford Hill Criteria to establish causation. And fourth, companies use this as a shield against responsibility. It's become a get-out-of-jail-free card for harmful products. The consequences are real. Vaccine hesitancy stems partly from misunderstanding correlations. Policymakers miss root causes like poverty when making education decisions. Companies waste millions on non-causal factors. Climate deniers dismiss overwhelming evidence. The solution? Causal inference literacy. We need to move beyond the mantra to actual investigation. Ask the right questions. What are alternative explanations? Is there a logical mechanism? Understand study hierarchy. RCTs are gold standard, but quasi-experimental methods like instrumental variables are powerful tools for real-world causal inference. Use this framework, the mechanism test. Is there a plausible pathway and dose response? The confounding test. What else could explain this? The replication test. Has this been found across different studies and populations? Remember, the goal isn't 100% certainty. It's building evidence strong enough to guide reasonable action. Correlation doesn't equal causation should be the beginning of investigation, not the end. It's a reminder to dig deeper, not dismiss evidence. If this changed how you see statistical arguments, smash that like button and subscribe. Check out our causal inference playlist and tell us in the comments, what correlation have you seen dismissed that deserves investigation? Stay curious, stay critical, and remember, good statistics is about asking better questions.